Right, we're going to talk about polarity. To start with, I just want to quick review the two types of bonds that we have worked with. We started with ionic bonds. To have an ionic bond, we had to have a metal. Let me get that working. We had to have a metal that wanted to lose electrons. And we had to have a nonmetal because nonmetals want to gain. So to have that ionic bond, we had a metal that would give up an electron to a nonmetal. An example would be sodium. It had one outer electron. If we take that and put it with chlorine, which has 7, in the outer shell, to get stable, chlorine would like to have 8. So the sodium gives 1 up to the Cl. That also makes sodium stable now as well, because sodium had 2 in the first shell, and it had 8 in the second shell, and it had 1 in that outer shell, that one right there. So if it loses that outer electron, it is down to 8 also. And that is what makes it stable. So this gives Cl a -1 charge because it gains, and it leaves the sodium a +1 charge. All right, so with an ionic bond, we have complete transfer. Have complete transfer of electrons from one atom to another. Because we have complete transfer, we have complete and opposite charges. With covalent bonds, let's get rid of all this. With covalent bonds, we have just the opposite. We've got 2 elements that want to do the same thing. So we end up with 2 nonmetals. They both have to gain electrons in order to get stable. So when they do that, they end up having to share. So if we take the example of H2O, and even though hydrogen sits over here, it is considered a nonmetal. And it's considered a nonmetal because it only has 1 electron altogether. And it doesn't want to give up that one and only electron. That makes it too unstable. So hydrogen always has to share. It won't give that up. So if we take hydrogen and oxygen is in the 6th family, that means oxygen has 6 electrons in that outer shell. It has to gain 2 in order to get stable. Just so happens that hydrogen only has 1. So that hydrogen will share with that oxygen, and that hydrogen will share with that oxygen. So to get everyone stable, we had to have 2 hydrogens. The number 1 rule for bonding is if the elements, all of the elements, don't end up stable, it won't happen. So this one is now stable. It has 2. This has 2, and that's all that the first shell can hold. And the oxygen is also stable because it has 8. All right, that is the basics of a covalent bond. But covalent bonds are not completely neutral, but they don't have full positive or negative charges either. In other words, the oxygen didn't actually take these electrons, it is sharing them. But what the oxygen does do is it tends to pull the electrons closer to it. That means that the oxygen takes on what we call a partial negative charge. That partial negative means that the electrons have been pulled closer to that oxygen. Well, if these electrons are closer to the oxygen, and this is partial negative, that means that these hydrogens are now partial positive because they don't have those electrons as close. This is what we call a polar compound. And what we mean by polar is the fact that even though it is a covalent compound, we have one end of the compound that pulls electrons closer to it. And that gives that end a partial negative charge. And it leaves the opposite end a partial positive charge.